All right, hello again. So today we are going to continue working with trig ratios in different quadrants. Um, and this is part two. So here's an example. We want to come up with the exact values of these three trig ratios given this condition. And the condition is that the point on a terminal arm is given to us. We need to find out where that angle, the standard position angle, lies, and then sketch the graph and then answer the question. Okay, the first thing we have to do, we need to draw the standard position angle, and here is the xy, quick xy sketch, Cartesian coordinate, and -3 is here, and this is approximation, is nothing exact. Minus √5 is there. The coordinate that we have is right there. That's the point. -3 minus √5. Okay, let's draw the terminal arm right there, and the standard position angle is the counterclockwise theta, because all of these are given the standard position angle being positive. Okay, what is, based on the coordinates, where is that the standard position angle? Well, it is in quadrant 3. Great, we know that. That means theta is between 180 and 270 degrees. So now we're going to go ahead and create these, find out all these ratios, sine, cosine, and tangent. All right, first we need to create that triangle. And remember, you're using that angle right there. That's a reference angle to theta. Because of you using the coordinates, you can actually say that's theta, but it's not. It's the reference angle to theta. That's how they're related. So we need to know, so this part is -3, which is the x side. The y value is -√5. Okay. And this is the hypotenuse or the radius, or for the triangle. Okay, and in this case we have 5 plus 9 is 14, and the radius is square root of 14. Now I said radius is because of that circle. Remember we talked about that is coordinate, so it's actually the path of these points. It goes around because the angle is circular, going around. It is, we say it's radius, but it's actually in this case is the hypotenuse. Okay, regardless of how you look at it, but that's what that is. Excellent. Now let's write up the ratios for each one. Sine of theta is -√5 over √14. Great. What is cos of theta? Cos of theta is adjacent, which is -3 over √14. And what is tangent? Tangent of theta is opposite -√5 divided by -3. So tangent of theta in this case is positive √5 divided by 3, because negative divided by negative is actually positive. So we answered the question. The standard position angle lies in quadrant 3. We came up with all the ratios, sine, cosine, and tangent, based on the diagram that we have. The terminal arm, actually the length of terminal arm, hypotenuse, radius of a circle, in this case, because we used the triangle, is √14. Great. Now here's a question. If we would have gone ahead and solved for theta, you can use any of these three trig ratios. Okay, let's use tangent. Okay, just for fun of that. You can use cosine and sine, but let's use tangent to actually find theta, and then we're going to go through the practice. So to do that, you got to do tan inverse of √5 divided by 3. Excellent. You punch in a calculator, √5. So here it is, 5. I'm going to take the square root of that, divided by 3, equals, I get that. Then I go to second function, tan inverse of that, and I get 36.7 degrees, 36.7 degrees approximation. All right, but this is in quadrant 36.1 degrees. Let's sketch that quickly. That's where that is. That's 36.7 degrees. This is in quadrant 1. But our theta, a standard position angle, theta is in quadrant 3. So what we're going to do to solve, to get the angle, the center position angle in quadrant 3? Well, here's a process again from last time. So basically what you want to make sure you're using the reference angle to this. So what is the reference angle to 36.7 degrees? Well, the reference angle is itself 36.7 degrees because it's an acute angle and it's between the x-axis and a terminal arm. Great. You draw the same terminal arm, same angle that is the reference angle on the terminal arm, but in a third quadrant. So here it is. I drew a terminal arm right here, and it doesn't have to be exact again, right? That is 36.7 degrees. So now the standard position angle is that. So what is theta? So theta now is actually 180 degrees plus 36.7 degrees. And that is 216.7 degrees. I think I'm adding this right. 20, yeah, it is. Great. All right. Now it makes sense because now we know that this angle in third quadrant must be between 180 and 270. And also you can check. And when you check that, you punch that in, you're going to get the decimal expansion. So this is the decimal expansion on top that you're going to get 0.75434. That's the decimal expansion of root 5 over 3. And when you punch that in, that's what you will end up getting for tangent. Now, you could have used any other ones, any other sine or cosine, and gone through the same process. But remember, if you always basically have to use the reference angle to the first standard position angle to find the second angle. Always you're going to do that in whatever quadrant that you're looking for. Okay, so this is the process. Now practice time.